This is an audiovisual presentation on calculus. Calculus is of two parts. We have differentiation and integration. Now, let's start with differentiation. Considering the graph as shown, y equals x squared is a curve. Y equals x squared is a curve. Now, assuming we have these 2 points on the curve, we have the first point with the x coordinate 3 and y coordinate 9. We have the second point with the x coordinate 4 and y coordinate 16. Now, let the first point be P. That is 3, 9, where 3 is the x coordinate and 9 is the y coordinate. And now, let the second point be Q1, 4, 16, where 4 is the x coordinate of the point Q1 and 16 is the y coordinate of the point Q1. Now, when we draw a line from P to Q1, it's a straight line. That is the line joining the 2 points. Now, we know that the gradient of a line is given by y2 minus y1 divided by x2 minus x1. Let's consider this tangent line, and a tangent is a line that touches the curved surface at a particular point. Now, this tangent line touches the curve y equals x squared at the point P, 3, 9, where 3 is the x coordinate and 9 is the y coordinate. Don't forget that the gradient is equal to y2 minus y1 over x2 minus x1. Now, assuming we are finding the gradient of the line PQ1, that is the gradient of the line joining P and Q1. Now, the coordinate of P is 3, 9 and the coordinate of Q1 is 4, 16. Take note that with the first point P, the x coordinate is 3. That is, so it means that our x1 is 3 and the y coordinate is 9. That means our y1 is 9. Now, with the second point Q1, we have 4, 16. That means that our x coordinate is 4. It means our x2 equals 4 and the y coordinate is 16. That means that y2 equals 16. So the gradient, which is equal to y2 minus y1 over x2 minus x1, will now be 16 minus 9. That is the y2 minus y1 divided by 4 minus 3. That is x2 minus x1. Now, 16 minus 9 is equal to 7. Divided by 4 minus 3 equals 1. So when we divide 7 by 1, the answer is 7. That means that the gradient of the line joining P and Q1 equals 7. Now let's proceed. Assuming we've located another point Q2 on the curve y equals x squared. The x coordinate of the point Q2 is 3.7 and the y coordinate of the point Q2 is 13.69. Now, how do we find the gradient of the line PQ2? We can see the line joining PQ2. Take note that the gradient is still y2 minus y1 over x2 minus x1. So when we consider these 2 points, P and Q2, the coordinate of P is 3, 9, and the coordinate of Q2 is 3.7 and 13.69. So the gradient of PQ2 will be equal to Y2, that is 13.69, minus Y1, that is 9. And that is how come we have 13.69 minus 9 divided by X2 is 3.7 minus X1 is 3, because we are considering the distance from P to Q2. That is the gradient of the line PQ2. So the gradient is equal to 13.69 minus 9 divided by 3.7 minus 3. Now 13.69 minus 9 is equal to 4.69. And 3.7 minus 3 equals 0.7. When we divide 4.69 by 0.7, this is equal to 6.7. That means that the gradient of the line PQ2 is equal to 6.7. Now, assuming we have also located another point, Q3, take note that we are moving closer to the point P. We are moving closer to the point P. So assuming that we have gotten another point on the curve, Q3, the x coordinate is 3.4 and the y coordinate is 11.56. So if you are finding the gradient of the line joining P and Q3, that will be 11.56, that is y2 minus y1, that is 9, divided by x2, that is 3.4, minus x1, that is 3. So the gradient will be 11.56 minus 9 divided by 3.4 minus 3. And 11.56 minus 9 is equal to 2.56 divided by 3.4 minus 3 equals 0.4. And this is equal to 6.4. So the gradient of the line PQ3 is equal to 6.4. Now, let's look at this. When we calculated the gradient of the line PQ1, we had 7. When we calculated the gradient of the line PQ2, we had 6.7. When we calculated the gradient of the line PQ3, we are 6.4. Now, when we look at what is happening, you realize that as we move closer to P, as we move the point closer to P as shown, the gradients start to decrease from 7 coming down. Now, when we continue moving the point closer to the point P, it gets to a particular point where the gradient of the line will be equal to 6. Where the gradient of the line will be equal to 6. That is, as we move closer to the point P, as we move closer to the point P, the gradient of the line between the point P and the other point closer to the point P will give us a value almost approximately equal to 6. Now there is something I'm going to show you here. So let's continue. Considering the curve y equals x squared, don't forget that this was our tangent line and the point P was 3, 9, where 3 is the x coordinate and 9 is the y coordinate. Now, y equals x squared is the equation of the curve. Y equals x squared is the equation of the curve. dy dx is equal to the gradient function. When you write dy dx, that means that we are differentiating y with respect to x. We are differentiating y with respect to x. So dy dx is what we call the gradient function. Now, how do we differentiate? In no time, you will know the principles of differentiating. But now, let's look at how to differentiate. When we consider the curve y equals x squared, the constant coefficient of the x here is 1. The exponent is 2. What you do is to multiply the exponent by the constant coefficient of the variable. So when you multiply 2 by 1, we have 2. Then we subtract 1 from the exponent. So we have 2 times 1. Take note that 1 times x is x. That's why the 1 cannot be seen. So 2 times the 1 will give us 2. And that's how come we have 2 here. Then we write our variable. the exponent is 2. We subtract 1 from the exponent. That is how come we have minus 1. So this is equal to 2x. 2 minus 1 is 1. So we have 2x exponent 1. And this is equal to 2x. Now divide dx. Where dy dx is the gradient function. So dy dx at the point where x equals 3. That's at the point where x equals 3. We mean the point P will be equal to 2 times 3. That means that from dy dx equals 2x. That's the gradient function. If you want to find the gradient at the point P, we need the x coordinate. So wherever we see x in the gradient function, that is dy dx equals 2x, we have to substitute it by 3. So instead of 2x, we have 2 times 3 because x is equal to 3 and 2 times 3 is equal to 6. That means that the gradient of the curve at the point P, 3, 9 is equal to 6. And the gradient of the tangent at the point of contact is also equal to 6. What I want you to understand here is that the gradient of the tangent is equal to the gradient of the curve at the same point. At the same point. That means that the gradient of the line AB and the gradient of the curve y equals x squared is the same at the point of contact. At the same point. And the answer is 6. Now let's look at the derivative of functions. In general, if you have y equals ax exponent n, we have y equals ax exponent n. N is the exponent. Now assuming a is a constant coefficient and x is a variable. Now when we write dy dx, this expression means that we are differentiating y with respect to x. How do we find dy dx? That is how we differentiate y with respect to x, and that is how it's written. This is equal to, we multiply the exponent by the constant coefficient. So we have n times a, and that will give us na. We write our variable, then we subtract 1 from the exponent, that is n minus 1. Take note, if you are differentiating, if you are giving y equals ax exponent n, and you are differentiating y with respect to x, it's written as dy dx. So we multiply the exponent by the coefficient, then we subtract 1 from the exponent. That's the principle for differentiation. So we have nax exponent n minus 1. Now let's look at this example. Find dy dx of the following. Y equals 4x cubed, b, y equals x exponent 5, y equals 7x exponent minus 3, y equals 5, y equals 2x cubed plus 5x squared, and y equals minus 6x exponent minus 2. Now let's see how best we can find dy dx of the following functions. Now solution A, we have y equals 4x cubed. 4 is the constant coefficient of the variable x, and 3 is the exponent. Now we have to find dy dx. That is, we are asked to differentiate y with respect to x. So we write dy dx. Take note, the rule for differentiation says that you multiply the exponent by the coefficient, then you subtract 1 from the exponent. So the exponent is 3, so we multiply 3 by 4, and that is how come we have 3 times 4. Then we have x exponent 3, then we subtract 1 from the exponent. 3 times 4 equals 12, so we have 12x. Now 3 minus 1 is 2, so we have 12x squared. That means that if y equals 4x cubed, when we find dy dx, the answer is 12x squared. Now let's consider the example in B. Y equals x exponent 5. Take note that here the constant coefficient of x is 1, but 1 times x is the same x. That's why the 1 cannot be seen, but it is there. So if y equals x exponent 5 and we are finding dy dx, that means that we are differentiating y with respect to x. So dy dx will be equal to, we multiply the exponent by the constant coefficient. So we have 5 times 1. That is how come we have 5 times 1. Then we maintain our variable x. Then we subtract 1 from the exponent. So 5 minus 1. Now 5 times 1 is equal to 5. So we have 5x, and 5 minus 1 is equal to 4. So dy dx is equal to 5x exponent 4. Now let's proceed. C, y equals 7x exponent minus 3. The constant coefficient is 7, and the exponent here is minus 3, and the variable is x. Now we have to find dy dx. So we are differentiating y with respect to x. So dy dx will be equal to, the exponent is minus 3, so we multiply the exponent by the constant coefficient. That is minus 3 times 7. And that is how come we have minus 3 times 7. Then x, then we subtract 1 from the exponent. That's how come we have minus 3 minus 1. Now minus 3 times 7 is equal to minus 21. Then we have x. And minus 3 minus 1 is equal to minus 4. So dy dx is equal to minus 21x exponent minus 4. Now d. We were given y equals 5. And 5 is a constant. But take note that 5 is the same as 5x exponent 0. Why did we express y equals 5 as 5x exponent 0? Because we are asked to differentiate y with respect to x. So in order to see x in the function, we have to multiply the constant given by x raised to the power 0. Why? Because x raised to the power 0 equals 1. And 1 times 5 is still the same 5. So nothing has changed. So y equals 5 is equal to 5x exponent 0. Now let's differentiate y with respect to x. So we have dy dx is equal to, we multiply the exponent by the coefficient. So 0 times 5. That is how come we have 0 times 5 here. Then x, 0 minus 1, because you subtract 1. After multiplying the exponent by the constant coefficient, we subtract 1 from it. So 0 minus 1 give us 0 minus 1. Now 0 times 5 is equal to 0. So we have x. 0 minus 1 is minus 1. But take note, 0 times anything is equal to 0. That means that dy dx is equal to 0. Don't forget, this means that anytime you differentiate a constant, please, the answer is 0. If you differentiate a constant, the answer is 0. Now, let's consider the example in E. Y equals 2x exponent 3 plus 5x squared. So we are differentiating y with respect to x. So dy dx is equal to, now we consider each term one after the other. So we multiply the exponent by the constant. So we have 3 times 2. That's how come we have 3 times 2. Now x exponent, then we are now subtracting 1. That's how come we have 3 minus 1. Plus, we multiply the exponent by the constant. So we have 2 times 5. And that is 2 times 5. Then we have x. Then we subtract 1 from the exponent. So we have 2 minus 1. Now 3 times 2 equals 6. So we have 6x. When we subtract 1 from 3, the result is 2. So we have 6x squared. Plus 2 times 5 is 10. So we have 10x. Now 2 minus 1 is 1. So we have 10x exponent 1. And this dy dx is equal to 6x squared plus 10x. Why? Because x raised to the power 1 is equal to x. So dy dx is equal to 6x squared plus 10x. Now f. Given y equals minus 6x exponent minus 2. The constant coefficient is minus 6. The variable is x and the exponent is minus 2. So dy dx means we are differentiating y with respect to x. And dy dx will be equal to, the exponent is minus 2. So we have minus 2 times minus 6. And that is how come we have minus 2 times minus 6. Then we have x. Already the exponent is minus 2, so we subtract 1. And that is how come we have minus 2 minus 1. Now minus 2 times minus 6 will give us 12. So we have 12x, and minus 2 minus 1 will give us minus 3. So we have 12x exponent minus 3. And this is equal to 12 divided by x raised to the power 3 with the help of indices. Because 12x exponent minus 3 is equal to 12 divided by x raised to the power 3. That is when we take the reciprocal, the sign will change from negative to positive. Now let's consider some applications of differentiation. We consider the rate of change. The rate of change of a quantity is the differentiation of the quantity with respect to time. The rate of change of a quantity is the differentiation of the quantity with respect to time. So the rate of change of radius r will be equal to dr dt. That is all. The rate of change of a quantity is the differentiation of that quantity with respect to time. So the rate of change of radius will be equal to dr dt. Now, assuming we are given a equals pi r squared, that is the formula for finding the area of a circle. Area equals pi r squared. Pi is a constant. Now, dA dt is the rate of change of the area, because we said that the rate of change of a quantity is the differentiation of that quantity with respect to time. So dA dt is the rate of change of the area. Now dA dt is equal to dA dr times dr dt, and this is what is known as the chain rule. Take note that the left hand side is equal to the right hand side. Nothing has changed. Why am I saying this? When the dr cancels the dr here, we are left with dA dt and we are back to the left hand side. So dA dt is equal to dA dr times dr dt. Now dA dr means you are differentiating the area with respect to the radius, and dr dt is the rate of change of the radius. So if you know the rate of change of the radius and you multiply by differentiation of the area with respect to the radius, then we have the rate of change of the radius, the rate of change of the area. I repeat, then we have the rate of change of the area. Now dA dr means you are differentiating the area with respect to the radius. We know that area equals pi r squared. So we multiply the exponent by the constant. So 2 times pi will give us 2 pi. Then we have r. The exponent is 2. When we subtract 1, 2 minus 1 will give us 1. And r raised to the power 1 is the same as r. That is how come we have 2 pi r. So dA dr is equal to 2 pi r. And dr dt is question mark. That means that if you know dr dt with our dA dr, we can multiply the two expressions and that will give us dA dt. That's the rate of change of the area. Now let's proceed. Example: the radius of a circle is growing at a rate of 20 centimeters per second when the radius is 4 centimeters. Find the rate of increase of the area. Find the rate of increase of the area. Now from the question, we are given the rate at which the radius is growing, and that is given by dr dt is 2 centimeters per second. We are given the radius to be 4 centimeters. Now the area is given by pi r squared. The area is given by pi r squared. Take note, when the question says the radius of a circle, so the figure in question is a circle, and we know that the area of a circle is pi r squared. So A equals pi r squared. Now dA dr means that we are supposed to differentiate the area with respect to the radius, and you know how to differentiate. You multiply the exponent by the constant coefficient, then you subtract 1 from the exponent. So 2 times pi will give us 2 pi r. Then you subtract 1 and that will give us r raised to the power 1, which is equal to r. So dA dr is equal to 2 pi r. Now dA dt from the chain rule is equal to dA dr times dr dt. So when the dr crosses out the dr, take note that our right hand side will be equal to our left hand side. So nothing has changed. This is what we call the chain rule. Now, dA dt is equal to dA dr times dr dt. And dA dr equals 2 pi r. That is what we have after differentiating the area with respect to r. We have 2 pi r. So dA dr equals 2 pi r. Now dA dr at the radius of 4 centimeters will be equal to 2 pi times 4. That is by substitution. And 2 times 4 is 8. So 8 times pi will give us 8 pi. So dr dt is equal to 2 centimeters per second. Dr dt is equal to 2 centimeters per second. From the question, dr dt equals 2 centimeters per second. That is the rate at which the radius is growing. The rate at which the radius is growing. So dr dt is 2 centimeters per second. Now from the chain rule, we know that dA dt equals dA dr times dr dt. And dA dr is equal to 8 pi. Dr dt is equal to 2 centimeters per second from the question. So dA dt will be equal to dA dr, that is 8 pi, times dr dt, that is 2. That is how come we have 2 here. So dA dt is equal to 8 pi times 2. And that is 16 pi centimeters per second. Now let's look at the maximum and minimum values. Let's look at what we call the maximum and the minimum values. If y equals f of x, then when we write dy dx, it means that we are differentiating y with respect to x. So dy dx, and this is called the first derivative. Now, when we write d square y over dx square, this is called the second derivative. Why is it the second derivative? It is the second derivative because we have differentiated y equals f of x twice. I repeat, if y equals f of x, when you differentiate y with respect to x, you have dy dx. We call this the first derivative. If you differentiate it again the second time, that is, if you differentiate dy dx, it will be equal to d square y over dx square. This is called the second derivative. Now, if y equals 4x squared, when you write dy dx, it means that we are differentiating y with respect to x. And differentiating y with respect to x, how do we differentiate? We multiply the exponent by the constant, so 2 times 4. And that is how come we have 2 times 4. Then x, we subtract 1 from the exponent, that is 2 minus 1. And this is equal to 2 times 4 equals 8. Then x, 2 minus 1 is 1. So, and 8x exponent 1 is the same as 8x. Now, d square y over dx square means we are differentiating it again the second time, and that is what we call the second derivative. Take note that the second derivative means you are differentiating the dy dx. And dy dx gave us 8x exponent 1, which was equal to 8x. So if you are finding the second derivative, that means if you are differentiating the 8x exponent 1 again, then you multiply the exponent 1 by 8, and that is 1 times 8. Then x, already the exponent is 1. So when you subtract 1 from it, that will give you x raised to the power 0. 1 times 8 is 8. So we have 8x raised to the power 0. And x raised to the power 0 is equal to 1. So 1 times 8 is equal to 8. So if y equals 4x squared, then dy dx equals 8x, and d square y over dx squared is equal to 8. Now, we look at testing for maximum and minimum values. Testing for maximum and minimum. Now, given x equals a and d square y over dx squared equals g of x. I repeat, given x equals a and the square y over the x square equals g of x. The square y over the x square is what you call the second derivative. So given x equals a, and the second derivative, the square y over the x square is equal to g of x. Let's take note of this. The square y over the x square at the point where x equals the a that was given is equal to, that means you have to substitute, because the square y over the x square is g of x. And so at the point x equals a will be g of a. If after substitution the answer you are getting is greater than 0, then it means that x equals a, that is x equals a, will give a minimum value. Will give a minimum value. Now let's proceed so you understand it better. Given x equals a and the square y over the x square is equal to g of x. Now, the second derivative, the square y over the x square, at the point x equals a, means we have to substitute a wherever we see x. And so this is equal to g of a. Now, if after substitution, the answer you are getting is less than 0, then it means that x equals a, that is the value, will give a maximum value. Will give a maximum value. So if it is less than 0, it will give a maximum value. But if it is greater than 0, it will give a minimum value. Now, example. The volume V of a cylinder has been found to be s cubed minus 12x. The volume V of a cylinder has been found to be s cubed minus 12x. Find the values of x for which the volume of the cylinder will be a maximum. The x values given are x equals 2 and x equals minus 2. So you are supposed to find the values of x for which the volume of the cylinder will be maximum. Which of these values, x equals 2 and x equals minus 2, will give us a maximum volume? Will give us a maximum volume. Now let's find out. Solution. The volume equation from the question is s cubed minus 12x. dv dx means differentiating v with respect to x. Now we know how to differentiate. Take note that the constant coefficient here is 1. So we multiply 3 by the 1, and that is how come we have 3 here. So 3x. When you subtract 1 from 3, we have 2. Now minus x here is x raised to the power 1. So 1 times 12 will give us 12. Then x. 1 minus 1 will give us 0. So x raised to the power 0 will give us 1. And 1 times 12 will give us the 12. So dv dx is equal to 3x squared minus 12. Now, the square v over the x square means that we are differentiating the first derivative. And so the square v over the x square is equal to, now we are differentiating everything here. So we multiply the exponent by the constant. So 2 times 3 is equal to 6. Then x. When we subtract 1, we have 1. And that is how come we have 6x. Minus, now there is a constant. And we know that when we differentiate a constant, the answer is 0. So 3x squared minus 12. When we differentiate it again, we have 6x. Now the square v over the x square is now equal to 6x. Take note that we were given these two x values, x equals 2 and x equals minus 2. So the square v over the x square, first we substitute x equals 2 into 6x. And that will give us 6 times 2, and the answer is 12. And we know that 12 is greater than 0. That means that this value will give a minimum value. If it's greater than 0, it will give minimum. Now, let's test x equals minus 2. So we substitute minus 2 into 6x. And that's how come we have 6 times minus 2. And 6 times minus 2 is minus 12. And minus 12 is less than 0. So if after substitution, whatever we are getting is less than 0, it means that that value we substituted will give us the maximum value. Will give us the maximum value. I repeat, when you are getting a value greater than 0, the x value you substituted will give you a minimum value. But if you are getting a value less than 0, then that x value will give you a maximum value. Hence, the value of x for which the volume will be maximum is x equals minus 2. Now, integration. This is the second part of calculus. Integration is the reverse of differentiation. What do you mean by this? Now let's look at this. If y equals 4x cubed, then dy dx means we are differentiating y with respect to x. So the normal rule, 3 times 4. So we have 3 times 4x exponent 3 minus 1. And 3 times 4 is 12. So x exponent 3 minus 1 is 2. So dy dx equals 12x squared. Now, assuming we are integrating the 12x squared dx, how do we integrate? For integration, we add 1 to the exponent, then we divide by the new exponent plus our constant of integration. Let's look at what we mean by that. We were given the function 12x squared dx to integrate, and the function itself is 12x squared. So we add 1 to the exponent, so 2 plus 1 divided by, now 2 plus 1 is 3, so we divide by 3, then plus c. So we have 12x cubed divided by 3 plus c. And 3 goes into 12 4 times, so we have 4x cubed plus c. Now you can see that when we were given y equals 4x cubed and we differentiated, dy dx gave us 12x squared. When you integrate 12x squared, you are getting back 4x cubed plus c, where 4x cubed was the answer, was the question, that is y equals 4x cubed. So when you are given a function and you differentiate to get an answer, you can integrate the answer and you go back to the question. Take note that c is the constant of integration. Now, in general, if you are integrating ax exponent n dx, a is the constant coefficient of the x, n is the exponent, and dx means we are integrating in terms of x. The rule is that if you have ax exponent n, you add 1 to the exponent, then you divide by the new exponent, that is n plus 1 plus your c, where c is the constant of integration. Now, definite integrals. Definite integrals are the integration with limits. Assuming we are asked to integrate from a to b, f of x dx, this will be equal to f of x ba. Take note, a is the lower limit and b is the upper limit. So after integrating f of x, we have f of x, upper limit b, lower limit a. How do we simplify this? First, we substitute our upper limit into the integrated function. So when you substitute b, we have f of b minus, we now substitute our lower limit, that is a into f of x, and that will give us f of a. So integral f of x dx from a to b will be equal to f of b minus f of a. Now let me show you what we mean by this. Example, integrate with respect to x the following: 2x cubed, 4x raised to the power 5, 7x exponent 4 plus 4x. Now a, given 2x cubed dx. Take note that these ones we are not giving the limit, so we call these ones indefinite integrals. The limit are not there. Now how do we integrate? The moment you start to integrate, take note that the integration sign will no more be there. The integration sign will no more be there. So we have 2x3, we add 1 to the exponent, then we divide by the new exponent. So we have 2x exponent 3 plus 1 divided by 4. Where from the 4, when you add 3 to 1, you get 4. So plus c. Now we have 2x exponent 4 over 4 plus c. 2 goes into 2 once, and 2 goes into 4 twice. So we have x raised to the power 4 divided by 2 plus c. Now b, integral 4x exponent 5 dx. This is equal to, let's integrate. We add 1 to the exponent, then we divide by the new exponent. So we have 4x, the old exponent is 5, so we have 5 plus 1 divided by 6, where 6 is coming from 5 plus 1 plus your c. Now we have 4x exponent 6 divided by 6 plus c. And 2 goes into 4 2 times. And 2 goes into 6. We have 3 times. So we have 2x exponent 6 divided by 3 plus c. Now c, integral 7x4 plus 4x dx. So how do we integrate? We add 1 to the exponent, then we divide by the new exponent. So this should be 7x 4 plus 1 divided by 5 plus 4x. Already the exponent here is 1, so we have 1 plus 1 divided by 2. We have 7x, 4 plus 1 is 5, so 7x exponent 5 divided by 5 plus 4x, 1 plus 1 is 2, so 4x exponent 2 divided by 2 plus c. Now 7x raised to the power 5 divided by 5 plus, take note that 2 goes into 4 2 times, so we have 2x squared plus c. Now let's look at this example. Integrate with respect to x the following. Integral 2x cubed dx from 1 to 3. So 1 is the lower limit and b, that is 3, is the upper limit. 1 is the lower limit, 3 is the upper limit. And the function is 2x cubed. And we are integrating in terms of x. Now b, integral 4x cubed dx from 0 to 2. C, integral 7x exponent 4 plus 4x dx from minus 2 to 3. Take note that the upper limit is always greater than the lower limit. The upper limit is greater than the lower limit. Now solution A, integral 2x cubed dx from 1 to 3. Now how do we integrate 2x cubed? We have 2x cubed, that is 3, then we add 1 to it, then we divide by the new exponent, 3 plus 1, that is 4. So we have 2x exponent 3 plus 1 over 4 plus c. The upper limit 3 and the lower limit 1. Now we have 2x exponent 4 over 4 plus c. The upper limit 3 and the lower limit is 1. 2 goes into 2 once, and 2 goes into 4 twice. So we have x raised to the power 4 over 2 plus c. Upper limit 3, lower limit 1. Now if you have x raised to the power 4 over 2 plus c, with the upper limit 3 and lower limit 1, this is equal to, first, you have to substitute your upper limit. So we have 3 raised to the power 4 over 2 plus c, minus, we now substitute our lower limit, that is 1. So we have 1 raised to the power 4 over 2 also plus c. Now 3 raised to the power 4 equals 81. So we have 81 over 2 plus c, minus 1 raised to the power 4 equals 1. So we have 1 over 2 plus c. Now we open up the bracket. So we have 81 over 2 plus c minus half minus c. Take note that the constant coefficient of the bracket here is 1. But because of the negative is minus 1. So minus 1 times half will give us minus half. And minus 1 times plus c will give us minus c. So plus c minus c will give us 0. So we are left with 81 over 2 minus 1 over 2. So 81 over 2 minus 1 over 2. And when you simplify, you have 80 divided by 2. And 2 goes into 80 40 times. So the answer is 40. Now let's consider the example in B. Integral 4x exponent 5 dx from 0 to. Now we integrate 4x, the exponent is 5, so we add 1 to it, and we divide by the new exponent 6 plus c. Upper limit is 2, lower limit is 0. Now we have 4x exponent 6 divided by 6 plus c. Upper limit 2, lower limit 0. And 2 goes into 4 2 times. And 2 goes into 6 3 times. So we have 2x exponent 6 over 3 plus c. Upper limit 2 and the lower limit is 0. Now we substitute the upper limit first. That is 2. So wherever we see s, we substitute 2. So we have 2 into bracket 2 raised to the power 6 over 3 plus c minus 2 into bracket 0 raised to the power 6 over 3 plus c. Now 2 raised to the power 6 equals 64. and 64 times 2 is equal to 128. So we divide by the 3 plus C minus, take note that 0 raised to the power 6 is 0. 0 times 2 is 0. 0 over 3 is 0. And 0 plus C is C. So minus 1 times the C will give us minus C. And plus C minus C will also give us 0. And this is equal to 128 divided by 3. So the answer is 128 divided by 3. Now the example in C. Integral 7x raised to the power 4 plus 4x dx from minus 2 to 3. Upper limit is 3, lower limit is minus 2. So now the normal rule for integration. 7x, the exponent is 4, so we add 1 to it, that is 4 plus 1. Then we divide by the new exponent, 5. Plus 4x, the exponent is 1, so we add 1 to it. That is 4x exponent 1 plus 1. Then we divide the answer by 2. Plus our constant of integration, C. The upper limit is 3 and the lower limit is minus 2. So we have 7x exponent 5 divided by 5 plus 4x squared divided by 2 plus C. The upper limit is 3 and the lower limit is minus 2. Now we have 7x exponent 5 divided by 5 plus, take note that 2 goes into 4 2 times, so we have 2x squared, and that is how come we have 2x squared here, plus C. The upper limit is 3 and the lower limit is minus 2. Now we have 7x exponent 5 over 5 plus 2x squared plus C. The upper limit is 3 and the lower limit is minus 2. So we first substitute the upper limit 3 minus, we now substitute the lower limit minus 2. So substituting the upper limit 3, wherever you see x, we substitute it by 3. So we have 7 times 3 exponent 5 over 5 plus 2 times 3 exponent 2 plus C minus, we now substitute minus 2. So we have 7 into bracket minus 2 exponent 5 divided by 5 plus 2 times minus 2 exponent 2 plus C. Now 3 raised to the power 5 equals 243. So we have 243 times 7 over 5 plus 3 squared is equal to 9. So we have 9 over 2 plus C minus, now minus 2 raised to the power 5 is equal to minus 32. So we have minus 32 to multiply 7 divided by 5 plus minus 2 squared is equal to 4. So we have 4 times 2. That is how come we have 4 times 2 here plus C. Now I give this to you as an exercise to simplify the expression and see if you get the answer to be 395. The answer is 395. This is the end of our